Every year, some of the largest machines ever built by humans quietly disappear from the world's oceans. Cruise ships, once filled with music, lights, and thousands of passengers, suddenly vanish from travel routes. Giant oil tankers that moved millions of barrels across the globe stop sailing for the final time. From the outside, it looks like retirement. But the truth is far more dramatic. Many of these floating giants are sold, towed across oceans, and dismantled piece by piece inside one of the most intense heavy industries on Earth. Steel worth millions, engines the size of houses, kilometers of cable, luxury interiors, and towering propellers are all stripped, cut, sorted, and sold again. Today, we're stepping inside the giant ship recycling industry. To answer one question most people never ask: where do old cruise ships go? Before we begin, don't forget to like this video, subscribe to the channel, and turn on notifications so you never miss our next deep dive into the giant industries powering the modern world. The story begins long before demolition starts. Ships are built to last decades, but not forever. Saltwater corrosion, rising fuel costs, changing environmental rules, expensive repairs, and new ship designs eventually make older vessels less profitable to operate. For cruise companies, passenger expectations also change. Travelers want larger cabins, modern entertainment systems, lower emissions, and newer amenities. For tanker fleets, efficiency and regulation often determine survival. At some point, the economics no longer work. A vessel that once generated millions in revenue can become too costly to maintain. That is when owners face a decision. Sell the ship to another operator. Convert it for a different use. Lay it up in storage. Or send it for recycling. And when a giant vessel enters the recycling market, the numbers become enormous. A large cruise ship may contain tens of thousands of tons of steel, copper wiring, stainless systems, aluminum fixtures, engines, pumps, generators, furniture, glass, electronics, and miles of piping. A tanker may contain even greater steel weight with huge machinery and cargo systems. What looks like an old ship is actually a floating warehouse of recoverable materials. That value creates an entire global industry. Once sold for recycling, the vessel usually makes one final journey. Sometimes it sails under its own power. Sometimes it is towed. Its destination is not a tourist port or oil terminal, but a dismantling yard. And this is where the scale becomes impossible to ignore. Across major recycling regions, giant ships arrive at facilities designed to break down structures larger than city blocks. Hulls tower above workers and machines. Deck after deck rises into the sky. Rusted names remain painted on the sides while tugboats guide them toward shore. For many people, it is the last time the ship will ever look whole. The first phase is preparation. Before cutting begins, crews remove fuels, lubricants, chemicals, loose waste, and reusable inventory. Safety teams inspect tanks, enclosed spaces, and structural zones. Valuable equipment may be identified for resale before heavy demolition starts. On cruise ships, interiors are especially important. Cabins contain doors, furniture, fixtures, mattresses, televisions, sinks, mirrors, and miles of decorative material. Restaurants contain kitchen equipment. Engine rooms hold generators, pumps, motors, valves, compressors, and electrical systems. Entire hotels are hidden inside the steel shell. On tankers, the priorities are different. Cargo systems, pumps, piping networks, valves, engine components, anchors, chains, and heavy machinery represent major value. Cleaning and gas-freeing procedures are critical before hot cutting can begin. Once preparation is complete, dismantling starts. And this is where the ship begins to disappear. Workers and heavy equipment open the structure section by section. Large steel plates are cut from decks, walls, hull sides, and internal framing. Cranes lift massive sections away. Smaller materials are manually removed and sorted. The pace can be relentless. A structure that took years to design and build can be reduced in months. Steel is the largest prize. A single large vessel may yield tens of thousands of tons of recoverable steel. That steel is cut into transportable sections, loaded onto trucks, and sent to re-rolling mills, foundries, and scrap processors. There it becomes beams, rods, plates, machinery parts, and construction material again. In many regions, recycled ship steel has helped supply local building booms for decades. But steel is only the beginning. Copper wiring is stripped and sold. Brass valves are recovered. Stainless kitchen equipment is resold. Generators may be refurbished. Marine pumps can enter secondary markets. Lifeboats, railings, furniture, windows, and even decorative wood panels from cruise ships sometimes find new homes. Nothing with value is ignored for long. This is why ship recycling is so labor-intensive. A vessel contains thousands of different components, each with different resale value, handling requirements, and hazards. One section may contain clean steel. Another may contain insulation, wiring, plastics, oils, and complex assemblies that must be separated carefully. That is why experienced dismantling yards can extract surprising value from ships that outsiders see only as scrap. Technology is changing the industry as well. More modern yards now use cranes, dry docks, impermeable working surfaces, drainage controls, waste capture systems, and structured cutting plans. Inventory tracking improves material recovery. Environmental controls reduce leakage and contamination. This matters because ship recycling has long faced criticism. Older vessels may contain hazardous legacy materials such as asbestos, contaminated residues, heavy coatings, or oily waste systems. Poorly managed dismantling can create risks for workers and coastal environments. That is why regulations and international pressure have pushed the industry towards safer, cleaner methods. The direction is clear. From simple demolition toward industrial material recovery. Cruise ships create some of the most fascinating recycling scenes of all. Because unlike tankers or bulk carriers, cruise vessels combine heavy marine engineering with hotel-scale interiors. Behind the outer hull are theaters, kitchens, elevators, shopping areas, pools, cabins, spas, restaurants, laundry plants, air conditioning systems, and endless corridors. Dismantling one is like recycling a skyscraper that floats. Tankers create a different spectacle. Their vast cargo spaces, giant pumps, engine plants, thick steel hulls, and immense anchors represent raw industrial scale. A retired tanker can seem less like a ship and more like a moving refinery being taken apart. And yet both end the same way, section by section, load by load, truck by truck. Until only the keel area remains. Then even that disappears. What once crossed oceans is reduced to sorted piles of reusable material. The timeline varies. Smaller ships may be dismantled relatively quickly. Mega vessels can take many months depending on facility capacity, market prices, labor, weather, and regulatory conditions. But the outcome is usually the same. Very little of the ship remains waste if recovery is done well. That may be the most surprising truth of all. Most people imagine old ships as abandoned relics. In reality, many are highly valuable at the end of life because they contain massive amounts of reusable metal and equipment. A retired vessel may no longer move passengers or cargo, but it can still supply raw material for cities, factories, and future products. From global tourism icons to giant oil carriers, these ships often finish their lives not in museums but in one last industrial transformation. From towering hulls arriving at the yard to cranes lifting steel plates into waiting trucks, from stripped cabins to molten reprocessing mills, the journey is larger and more complex than most people ever imagine. And it happens quietly around the world every year. Inside the giant ship recycling industry, old cruise ships do not simply disappear. They are dismantled, sorted, sold, melted, and reborn into something new. If you enjoyed this deep dive into one of the world's most dramatic hidden industries, make sure to like the video, subscribe to the channel, and hit the notification bell so you never miss our next look inside the giant systems powering modern life. Thanks for watching. With more than 140,000 miles of active railroad track in the United States, supported by over 800 million wooden railroad ties, America quietly replaces tens of millions of these massive timber beams every single year. But here's the part most people never see. Old railroad ties don't simply disappear. Instead, they enter a hidden industrial system where weathered, oil-soaked wood that once carried 1,000-ton trains is collected, sorted, processed, and transformed into fuel, construction materials, and industrial products. Today, we're stepping inside America's supergiant railroad tie recycling operations. Before we dive in, don't forget to like, subscribe, and turn on the notification bell so you never miss our deep dive documentaries into the industries that quietly power the modern world. Wooden railroad ties, also called sleepers, are far tougher than ordinary lumber. Most are made from hardwoods like oak, treated with creosote, a heavy preservative that protects against rot, insects, and extreme weather. A single tie weighs between 150 and 300 pounds and can remain in service for 25 to 40 years despite constant vibration, temperature swings, moisture, and enormous loads. Every passing freight train can weigh over 10,000 tons, and each axle pounds the ties thousands of times per day. Eventually, however, even these rugged timbers crack, warp, or decay, requiring replacement to maintain track safety. The journey of recycling begins along the rail lines themselves. Maintenance crews travel the network using specialized machines designed to extract old ties without dismantling the entire track. Tie removal machines lift the steel rails slightly, while hydraulic arms pull damaged ties sideways out from beneath them. New treated ties slide into place, ballast is tamped, and the rails settle back down. All in a continuous operation that can replace thousands of ties in a single shift. The removed timbers are stacked beside the track in long rows, waiting for collection. From there, fleets of trucks equipped with hydraulic grapples gather the ties and transport them to consolidation yards. At these staging sites, mountains of dark, weathered wood pile up, some still bearing rusted spikes, steel plates, or fragments of ballast embedded in their surfaces. The air often carries a faint tar-like scent from decades of creosote exposure. Each load is weighed, documented, and inspected because the treatment chemicals classify ties as specialized waste requiring controlled handling. Sorting is a critical step. Not all ties share the same fate. Some are still structurally sound despite surface wear. These reusable ties may be sold for secondary applications such as landscaping walls, farm fencing, or industrial ground stabilization. Contractors value them for their durability and resistance to decay. Other ties, however, are too damaged, split, or contaminated for reuse and must undergo industrial processing. Before further treatment, metal components must be removed. Old spikes, bolts, and rail plates are extracted using hydraulic shears and magnetic separators. Large stationary machines can rip embedded hardware from the wood in seconds, sending recovered steel into separate recycling streams. This step protects downstream equipment from damage and ensures clean material recovery. Once stripped of metal, the ties destined for energy recovery move to heavy-duty shredding systems. These machines are built to handle some of the toughest wood products on Earth. Conveyor belts feed ties into slow-speed, high-torque shredders equipped with hardened teeth capable of crushing dense hardwood and residual metal fragments. The process is loud and powerful, reducing massive beams into irregular chunks. Secondary grinders then process the material further, producing coarse wood chips suitable for industrial use. One major destination for this material is biomass energy production. Treated wood contains high calorific value, meaning it burns intensely and efficiently when used in controlled facilities designed to handle treated timber. Specialized power plants or industrial boilers use the chipped ties as fuel to generate steam and electricity. Advanced emission control systems capture pollutants, ensuring compliance with environmental regulations. In this way, wood that once supported trains can end its life-generating power for factories, district heating systems, or manufacturing operations. Another pathway involves engineered materials. Some facilities process tie wood into composite products used in heavy-duty construction or infrastructure. Because the timber is extremely dense and durable, it can serve as a reinforcing component in certain industrial applications where untreated wood would fail. However, strict regulations govern these uses due to the presence of preservatives. The scale of operations at major processing centers is astonishing. Giant loaders maneuver across yards filled with towering stacks of ties, lifting several tons at a time. Conveyors stretch across entire facilities, linking shredders, grinders, and storage silos. Dust suppression systems spray fine mist to control airborne particles. Control rooms monitor throughput, equipment load, and safety parameters around the clock. Some sites process thousands of tons of material per week, operating continuously to keep up with the relentless pace of rail maintenance nationwide. Environmental considerations drive much of this industry. Disposing of creosote-treated wood in landfills is heavily restricted because the chemicals can leach into soil and groundwater. Recycling through energy recovery or controlled industrial use provides a safer alternative while extracting remaining value from the material. In addition, recovering metal hardware reduces the need for new steel production, further lowering environmental impact. Economics also play a role. Railroad companies face significant costs to replace aging ties, so efficient recycling systems help offset disposal expenses. Energy producers benefit from a steady supply of high-energy biomass fuel. Recycling firms generate revenue by processing and selling both wood chips and recovered metals. This interconnected network creates a circular system where infrastructure renewal feeds industrial supply chains. Despite its scale, the industry remains largely invisible to the public. Most people never see the massive operations handling these heavy timbers after removal. Yet every day, thousands of old ties are quietly transported, processed, and transformed across the country. Without this system, maintaining the rail network, a backbone of freight transportation, would generate enormous waste challenges. The life cycle of a railroad tie is remarkable. It begins as a tree harvested decades earlier, is treated to withstand extreme conditions, supports millions of tons of passing trains, and ultimately transitions into fuel or industrial material rather than ending in a dump. Few construction components experience such an intense and prolonged service life followed by large-scale recovery. As rail traffic continues to grow, tie replacement will remain constant. New technologies such as concrete or composite ties are being introduced in some applications, but wooden ties still dominate due to cost, flexibility, and ease of installation. This ensures that recycling operations will continue for decades to come, adapting to evolving regulations and sustainability goals. If you enjoyed this journey inside America's supergiant railroad tie recycling operations, make sure to like, subscribe, and hit the notification bell so you never miss our next exploration into the incredible processes behind the infrastructure that keeps our world moving. Your support helps us uncover the hidden stories behind everyday materials. Thanks for watching. And remember, even the strongest foundations eventually change roles, but their impact never truly disappears.